This video here, we're going to be looking at like terms. So the key things that hopefully by the end of this lesson, you do know what the term like terms means, and also what simplifying means, or combining like terms. So the first key point you're going to need to make sure you write down is what is like terms. So like terms are terms, and I'll highlight here, that contain exactly the same pronumerals. So remember the pronumerals are, I guess, basically the letters that we use in algebra. And also exponents, or otherwise known as powers, are the same. So that by powers, I mean, something says b squared. That is what we refer to as, sorry, I'll move it there. That's what we refer to as exponents or powers. Okay. So another important note that you need to remember with this is that pronumerals do not necessarily have to be in the same order. Okay, so we know, and we'll get a look at an example of that very soon. But let me give you an example of like terms and things that aren't like terms following those rules. So the first one we have here is 5ab plus 3ab. Now these have the same pronumerals, so they are like terms. So we can combine those or simplify those. Next one we have is 4a and 7b. Now again, the pronumerals in this one aren't the same. We've got an a and a b, so we can't combine them or simplify them. So they're not like terms. The other way, and similar to our note up here, is we have 2acb and 4bac. Now if we really look at it, we have a c and a b, and we also have an a c and a b. So they are actually like terms, because remember we said it doesn't necessarily have to be in the same order, but these are like terms because they have the same pronumerals, an a b, and a c. They're just in a different order. Now when these two here aren't like terms, because we have 2b squared and 3b to the power of 3. And as we said before, they need to have the same exponents. In this case, they don't. We have a b squared and b cubed, so we can't combine those like terms. Now, the key term that we need to identify here is when we're simplifying. So simplifying basically means collecting like terms. So we collect like terms to create a simple expression. So this example that we had here, this was one that we saw before. We have 5ab plus 3ab. And what we can actually do is combine them or simplify it to make a more simplified expression. So we can combine 5ab and 3ab, which would give us 8ab. So that's what we mean by simplifying. We're not solving, we're not doing any of that. We're just simplifying it to make an equivalent expression. Now, if two terms are not like terms, for example, 4x and 5y, they can still be added to get an expression. So 4x and 5y, we can do that to become 4x plus 5y. We just can't simplify it or make it smaller. We're just adding them together. So let's do a bit of practice here now, and we'll determine which of the following are like terms and which ones are unlike terms. And I'll write L next to the ones that are like and U next to the ones that are unlike, and I'll explain my thinking as we go. So first off, we have 3x and 2x. I can see that they both have the same pronumerals x, so this is a like term. The next one here, 3a and 3b. Easy, different pronumerals, an a and a b. We can't combine them, so they are unlike terms. Now number C says 2ab and 5ba. Yes, they're in different order, but they also just contain an a and a b. Okay, and as we said before, they don't have to be in the same order, so we know that these are like terms. Now 4k and k, just because it doesn't have a number in front of it, it doesn't mean that it's not, they're not common. So really what we're doing here is just adding this k to this one. So 4k and k, they are like terms because they've got the same pronumeral, so this is also a like term. Now 2a and 4ab are unlike terms, and the reasoning being this one has an a in it, but this one has a and a b, so it's an unlike term. Similar to this one underneath, we have 7ab and 7aba. So again, if we just looked at the pronumerals, this one has just one a and one b, this one has two a's and one b, and if we wrote that down simplified, that would be 9a squared b. Okay, and we know that because the exponent is different to that one, they are unlike terms. So now we'll get into the real nitty-gritty of it. So now that we understand like terms, what we want to do is practice simplifying. So if we get an expression like this, we have 7b plus 2 plus 3b. we're going to go through the process now of simplifying. We do that just by combining the like terms. Again, we're not solving, we're not doing any of that. We're just trying to simplify it and make it smaller. And we do that by collecting the like terms. So if I underline the like terms here, you might be able to see it a bit easier. And what we do is we just combine them together. So I might put them next to each other. So I have 7b plus a 3b plus 2. And these are my like terms here. So I'm going to combine them together. So 7b plus 3b equals 10b. And then I just have add 2 because that's not a like term. So I've just simplified that expression. And we could also do it when we have subtraction. So here I can see that I've got 3 like terms. They all have a pronumeral of d. So I can combine these now. So 12d minus 4d would equal 8d. And then I'm adding another d, which would give us 9d. So just combining all the same pronumerals. And the reason we want to simplify is because we're often going to get expressions like this that are really quite long. And when we can often get daunted when we look at this, but when we actually simplify, it can be quite easy. So let's collect all the like terms. I'm going to start off by, okay, I can see I've got a's. Okay, and I'll keep this subtraction there. I've got a b here, and then I'll just usually have my constants here. So I'm going to combine all those ones together. So I have 5 plus 12a. And I'm going to move that negative 3 over to here, minus 3a, plus 4b, minus 2. Okay, so I'm going to combine these ones first. So what I have is 5 plus 12a minus 3a equals 9a, plus 4b, minus 2. And also notice that I've had combine my constants there, which is 5 minus 2, which will give us 3 plus 9a plus 4b. Okay, so this now looks a lot easier than that large expression there, and I've done that simply by simplifying. The last one here, again, a bit of an extended one, which we'll do, and we'll go through first and find our like terms. So I've got a's, I've also got, if I change colour, I've also got some b's here as well. So they're going to be the like terms that I will change here. So I'll collect them first. I'm going to have to start with an a. So I've got 13a plus a 2a minus a 4a. And then I have an 8b minus a 5b. And what I can do is I can just focus on each of those pronumerals there, or those like terms, and combine them there. So 13a plus 2a equals 15a, minus 4a equals 11a. Okay, and then I have 8b minus 5b, which will equal 3b. Okay, and now that gives me a nice simplified expression from there. Again, anything that doesn't make sense, make sure you're writing those questions down or highlighting any key parts so we can discuss that in class, and then we can go from there. But again, just a reminder that like terms, it's just those things that have the same pronumeral and also the same exponent, and we simplify just by collecting those like terms and making a simpler expression. Thanks, guys.